Hi, I'm Paul Jermain, and welcome to another session of Smart Boating. As you know, if you watched the show before, we cover a variety of topics, from hurricane protection to chartering. And the basic idea is to provide you with information that will help you make better choices in the water and have more fun. And today, we're at the landing school, where they get involved in a lot of interesting areas that I think are going to impact your boating in the near future. So we've got a variety of guests, and our first guest is Richard Schumann of the landing school. Richard?
Morning, Paul.
Good to meet you.
Welcome to the landing school.
Thank you very much. Hey, we got a cool show here today, but before we get into it, can you share a little bit about your boating background and a little bit what the school does?
Yeah, sure. I've been boating since I was a little kid growing up on Long Island, starting with rowboats in Manhasset Bay, and eventually went on to become an underwater archaeologist. So I would, when I went to work in the morning, I went to work on a boat, worked in the oil fields of the Gulf of Mexico. So I've spent my whole life really around boats.
Yeah.
And as a matter of fact, I was a student here at the landing school back in 1986. So that's dating me a bit.
Right. How about what do you do here at the landing school? What's the main focus?
So our main focus here at the landing school is to prepare men and women for really amazing careers in the marine industry. We're the only school in the world that offers academic programs in wooden boat building, composite boat building, marine systems, and yacht design, all under one roof.
One umbrella, yeah.
One umbrella. And in fact, we're the only residential yacht design program in the entire United States of America.
Really?
It's hard to believe, right here at little 286 River Road in Arundel.
Right, exactly. All right, well, it sounds like you've got just the right background, just the right things going on here for the show. So why don't we get right into it?
You bet. Come on, let's take a walk.
Okay. Well, Richard, you know, there's a lot of stuff going on here at the school. But I thought today we just talk about maybe some of the core activities.
Great.
And we're here in the Design Loft. Can you share with people a little bit about what happens here? Because we're going to get into a couple boat examples in a minute, but maybe you could provide an overview first.
Sure. And you know how I like to explain what happens here at the school is that we're involved in imagining boats, designing boats, building boats, and helping to keep boats operational. Those are the four things that we do here.
Okay.
So what you see in this area here is really where boats are imagined and they're designed.
Right. Like this one behind us here.
This one behind us here, right. This is an example of a boat we built several years ago. It's a Fly Fisher 22. And as part of the design process, we're really teaching students the importance of designing strong boats that have utility, so they actually perform a function,
with them, right?
And then also that they're beautiful, they're aesthetically pleasing as well. Those are the three core attributes of the boats that students are expected to design. Correct.
Well, we've got some examples of some boats here that are the sort of things that you would design here.
Right.
We've got two boats, a 17-foot and a 19-foot on the left and right. Can you help us understand maybe a little bit about the background of the one on the left first and then have the one on the right contrast with that?
Sure. And this is a really interesting example of two boats that were designed and built here at the school. A 17-foot runabout and a 19-foot center console.
Yeah.
And the critical difference between these two boats, other than the fact that one is 2 feet longer than the other one, is the sourcing of materials.
Okay.
With this first boat, the 17-footer, all the materials that were used to build the boat were sourced from overseas.
Okay.
What we did was we did a redesign and a reconceptualization of the boat to make sure that the new design was structurally equal to or superior to the first one. Secondly, that the second design had utility equal to or greater than the first one.
Right.
And third, that the aesthetics of the second boat were equal to or greater than the first one.
Right.
But also what we said was, instead of sourcing 100% of our construction materials from overseas, let's source 100% of our construction materials from New England and from the United States.
Right. And you were interested in low carbon footprint too, right?
Well, you know, it started out looking at ways to economize. So the materials from overseas are conventional materials, but they're quite expensive.
Yes.
By sourcing locally, we wound up cutting our materials cost by 60+% while increasing the boat length by 2 feet.
Excellent.
We wind up keeping our money here in our local community instead of sending it overseas.
Right.
And also, sort of a tertiary thing, the carbon footprint was decreased by over 90%.
Wow.
So it's one of those rare win-win-wins that I don't know about you, but I don't find very often in life.
That's true. That's true. Now you guys have one of these under construction right now, right?
Yeah, we've got an Arundel. This is the Arundel 19. We have an Arundel 19 under construction right now downstairs, and we can go have a look at that if you like.
Excellent. Jamie, you know, I was just talking to Richard about some of the interesting boat designs you have, and now we're down in the shop to show you do it, and this is part of the operation you're in charge of. We've got a couple drawings behind this, or plans, really.
That's correct.
Drawings.
These are construction plans.
Construction plans. Let's take a look at this one first, because these both relate to the boat behind us, right?
That's correct. These are construction plans for the Arundel 19, which is right here behind us in construction.
Yes. Yes, can you explain what is depicted in this drawing here?
This construction drawing shows, first of all, on the right-hand side here, a list of materials and where they apply in the boat.
I see.
And this also gives us dimensions and a proximity of where things would go in reference to this list of materials.
Okay, good, yeah. So this is, you need these as a start to go from a broad plan to a detailed plan that you can build.
That's correct.
Right? Yeah.
Another set, there's several sets of plans depending on the complexity of the boat that you would get.
Yes.
We have a set of lines plans which designates the shape of the boat, and that's lofted into a full scale.
Right.
From that, the hull is made, and then the components start to be made, which are fit into the boat according to both, I said, materials and where they're located.
Yes, yes. And how about this drawing here? This is another view, and if we focus on the bottom of it right here.
Yeah, so this is a sectional construction section plan.
Okay.
And it gives you sections of the boat, or what we call a transverse section. In other words, looking at the boat in profile, we can take a knife and cut it into sections. And this shows us a construction detail at the deck. And down here, what you were referring to is a frame in reference to the planking, and a deck and floor timber in reference to the keelson and the keel.
Okay. Again, it's kind of like a map of how to put the boat together. What goes where?
That's correct. And this gives dimensions so that students or builders can determine what size is appropriate for what application.
Okay. So you get the plans together, you look at them carefully, and then I know you guys are doing experimentation, research, trying out different ways to use local woods, local materials.
We're working really hard to stay at least in New England for our selection of species.
Yep. And you've got some examples there, right?
Yes, I've got a piece. We use what's called eastern white cedar, or northern white cedar, excuse me.
Northern white cedar, okay.
And this is a piece of ripsawn, and we've used it in both seats, thwarts, and or in planking stock.
All right, cedar's good because it's in low rot. It's rot resistant, right?
It is. Not the whole plank or the whole tree, but most of it. So there's different parts of it are more durable, what we call durable, than other parts.
Interesting. Okay.
We've got a piece of white oak here. And this white oak is mostly for our structures in regards to stems and keels.
Very strong,
sometimes transoms, extremely strong. It's also used in frame stock, and we'll talk about that in a bit.
Okay.
One of the things we do with white oak is we create floor timbers, which are transverse, like in our sectional plans right here.
Yep. Yep.
We also use white pine. Eastern white pine, and this is sort of an example of how the planks would go onto the frames, which are white oak. And we also use a really unique species to New England called black locust. We've used it on the keel. We've also used it in the transoms.
Yeah, that's very rot resistant.
It's extremely durable, very rot resistant, and it also kind of has a mind of its own.
Oh, it does.
So it's unique in that regard.
Okay. Well, Jamie, you get the drawings, and you lay it out, and you get the materials. And then you've got to create a structure on which to build the boat on. Can you tell us a little bit about the structure that we're standing behind?
Absolutely. So our setup for any boat includes what we call molds.
Yep.
And the molds are a component. And it looks a little ragged because it's been through, already gone through, if you would, its setup phase. But it has several component pieces, and they're held together with our what we call blocks or backing blocks. All these shapes of these pieces of pine are taken off our loft floor.
Right.
And so, and this spall line, this represents the plane of this bottom, represents what we call a water line. And the water lines are parallel. They run longitudinal through the entire setup structure.
Yep. Okay.
And this particular part of the structure was up here in the bow. It was about in this location, approximately. We also have this particular bulkhead, or this bulkhead rather, which is this part right here. A bulkhead is a structural component to a boat, and I'm putting it up in orientation. Oops, sorry, Paul.
Yeah, that's all right.
And setting up in orientation to the way the boat is.
Right. So use this as the template to cut that.
That's right. This came out of that section. So if you look at it, and this is a component that we build out of white pine. We vacuum bagged 3 layers of white pine to create our own panel.
Okay.
So once again, rather than plywood, we're attempting to substitute our native white pine in a vacuum bagged epoxy manner.
Right.
Instead of the plywood. So that came from this section right here.
All right.
So you can see how different places in this setup reference directly to where it is in the boat.
Yes, yes, yes. So this is the first step. So you're putting all the framing together and get all the pieces cut out, and you're building. This is actually the bottom of the boat right here.
We plank over this whole structure and
Plank
create
over
the
this.
hull.
Right. Excellent.
Yeah.
Jamie, when you're building a boat, there's a lot of interesting techniques you have to work with because you got a lot of angles and curves and that sort of thing. And it seems like one of the things you have to do is take hard wood, solid, rigid wood, and make it soft, right?
Yeah. For instance, our frames, which are made out of white oak, are right out of the plank of wood. After we saw them, they're pretty stiff.
Very stiff, yeah.
But once we take them out of the steam box, and this one's just out of the steam box, it becomes extremely pliable.
Oh, yeah.
I mean, to the point where, without me doing any harm to myself here, we can pretty much bend it
Oh, yeah.
to whatever shape we would like.
Yeah.
And that's how they fit inside the boat to create their shapes. And then we hold them in place with wood screws.
And then they'll take a set.
And they set, that's
Yeah.
right.
Yeah. Wow, that's interesting.
Yeah, it's pretty cool.
Yeah.
You can try that yourself if you'd like.
All right. So I bring it up here. And, oh, yeah. Oops, that one snapped a little bit. That needs more time in the steam box.
Nope, that one's a failure.
No, I understand that.
Mother
but
Nature.
Yeah, Mother Nature. Okay. So that's one thing that's important when you're building a boat. And how do you attach the planks to the ribs and the planks to the planks?
There's a lot of techniques that we use. One of the ways we just talked about, we have wood screws that hold things planking to frame.
Yeah.
We also have what we call riveting. And the riveting is a process where the material's all copper.
Yeah.
And we have
Got some pretty small nails there.
very small copper nail,
Yeah.
and even smaller
Little
is what we
washer
call
there.
the rivet, the rove rather.
The rove, okay.
And so
Like a
the
little
process, that's right, a little copper washer. So the process is that the plank and the frame are already fit to each other, and now we drill the hole and we drive the copper nail, the rivet, through the plank and through the frame.
Oh, okay.
And once we get it to the other side, let me hold that still. Once we get it to the other side, we use we have a variety of different tools.
Yeah.
We have a little piece here called a rove set.
Yep.
That fits over top of the rivet and holds the rove in place.
Yep.
And then we have a backing iron, which is a 2-man operation.
Okay.
We back the rivet up
Yep.
from that side.
All right.
And then we have a set of snippers. And we snip the rivet off, flush with the rove. And then we take a ball peen hammer, and if things go well,
Yeah.
we peen over the rivet. Onto the rove, and we hold the two secure.
That's good.
Well, we hope it's good.
Good. Jamie, we're on the inside of the boat that we've been talking about, an example of a 19-foot Arundel. And you've got the ribs here, you got the planks in, got the keel in. Can you explain a little bit more of what we're looking at here?
Yeah, students have spent quite a bit of time what's called fairing up the inside, sanding it smooth.
Oh, yeah.
Once again, frames are called transverse structures, and right now they're fitting what's called floor timbers,
Yep.
which in this case they span the keel,
Yeah.
and they go endless from port to starboard.
Yeah.
They're notched over top of the keel.
I see.
And once again, this is a transverse structure
Yeah.
that gets bolted to the keel and screwed through the frames and into it.
Okay.
So that starts giving a lot of rigidity, especially in power boats,
Yeah.
transverse.
Yeah, that stiffens it up. Now, from the time you get the design plans
Yeah.
to the time it's ready to hit the water, how long does that typically take?
Well, the planking planking process, the lofting process is the first thing.
Yes.
And from lofting and setup to end of planking is just about 10 and a half to 11 weeks.
Okay.
Then we move into having different parts of the inside put in, just like the structure part. And eventually we move, and we talked about the bulkhead earlier.
Yes.
So things like bulkheads, there's another one aft. So the components start to build themselves and the boat gets more and more complete.
Yeah.
Launching this time this year, it's going to be second week in June. So we'll have a week of sea trials and last minute items.
Richard, I was just talking to Jamie, and we were showing how the boat was built, and we got the result behind us. Really pretty boat. What are you most proud of? What are the highlights of this boat that really stick out for you?
Well, as we discussed before, I'm delighted that we're able to source 100% of our materials from our local community.
Yes.
Really like the idea of investing in our local community.
Yeah.
I also like the fact that I'm spending 40% less than I was on that 17-foot boat.
Yeah.
I really like the fact that we've knocked our carbon footprint on the materials down from about 2,000 pounds of CO2 for the 17-footer down to about 100 pounds for this boat. And that's really remarkable.
Yeah.
And a lot of folks have become excited about this process.
Oh, yeah.
We've gotten foundation support from the Bonnell Cove Foundation, Ferguson Foundation, and most recently from 11th Hour Racing, which is a Schmidt family foundation based out of Newport, Rhode Island, who have supported us financially in the development of a software tool with which we quantified the carbon footprints of all these materials. So it's a sort of a chemical accounting program. And we're excited that we're going to take it now and take this application from wooden boat building over into evolve it into composite boat building. That's our next step.
Well, Chris, you head up the composites area here at the landing school, and really the materials in boat building have changed dramatically over the last 20 or 30 years. Can you lead us through kind of an evolution here and help us highlight the changes that have occurred?
Sure. I guess when everybody thinks of a traditional composite material would be your typical balsa core and fiberglass layup kind of stuff. And this stuff's been around forever, and it's still used a little bit today.
So how do they join it? They use the resin and the fiberglass and put them together?
So yeah, basically, the old school technique is called cup and brush.
Cup and brush.
Basically, we got a cup of resin
Got
and a brush
right there.
and our fiberglass material. In the old school, you just kind of take it in the cup and you brush it on the material, and it's called open molding.
Open molding.
Open molding.
Okay.
And there's some emissions issues, and guys get dirty and stuff like that. So the industry's trying to kind of move away from that kind of stuff.
But in terms of going from this is really a composite here, right?
Yeah, absolutely.
When we put a resin and a cloth material or something, those two coming together, that's an example of a composite.
Right. Fibers held in a matrix by resin.
Right.
That's a definition.
So that's been around for a long time. My old Bertram's made of that.
Oh, yeah.
But then they went to coring, right? They started saying, how can we maybe drive some weight out of this and keep it light and strong?
Right. Get a little stiffness.
Get some stiffness. So that's when the balsa started coming in, right?
started to come in.
Yeah. And that's it's got some issues. One of the issues is gets wet, right?
Right. With this old technique and trying to mix those two together, there's ways for water to get into that, and everybody's seen wet balsa core.
Yeah, and then you got to cut it out and do a big job. Yeah,
right.
Big job. Okay. Right. So that's where we started with just the glass and the resin. Then we started doing the balsa. What happened next? What was the next thing?
So the materials have changed. So from some of the heavier things, the manufacturers got better at making the material, making it into smaller fibers, which makes it easier for people to handle.
Yeah, like this one here.
So this one's got a smaller fiber bundle to it, and it's got better drape. It goes over stuff a little easier.
Right.
For formability of stuff.
Yep.
And some of the other materials, and so we've gone from a wood natural fiber to a synthetic, a foam core material.
Yes.
And people probably heard of core cell or something like that.
Yep.
And this
Very
is
popular.
what that core cell was.
Yeah.
And you can still do that with an open molding process, but you're not quite getting the strength out of it.
But you get more rot resistance, right?
You get,
absolutely.
the
water
water
with the water, right?
The water doesn't affect this at all. And the techniques have come up a little bit with a vacuum bagging process. So from a complete open molding to now we can wet it out and then put this into a vacuum bag and compress it and get a little bit of properties out of it.
Okay, all right. So a lot of boat builders would be using this, right? They use the cloth of the roving, plus they use the cell, some sort of cell.
Core cell,
to get away from the balsa, right?
Right.
Yep.
Give us some more rot resistance.
And then we've got some, it seems like the evolution keeps moving.
It does. It keeps moving. It changes
Just like
daily. It's
us
crazy.
here. And this one, it looks like an old bag or something. What's going on
A
with this?
potato sack. Is what I call
Potato
it.
sack. All right. All
It's
right.
burlap. It's a
Burlap.
natural fiber.
Yep.
Jute, maybe some people know it as that, or Cecil rope, the same kind of stuff.
Okay, right.
A lot of the car manufacturers and stuff, if you've ever seen the inside of a door panel or something,
Been a while.
that brown stuff, it's usually made out of this. So
Really?
It's been around for a while. And we're
Okay.
trying to find some new areas and ways to use this stuff because it is a natural fiber. And it's better for everybody, I guess.
I see. All right. And this is a panel that's been made of that, using that.
So we've gone back to a wood core on this one, but
yeah.
we've skinned it with this natural fiber.
Okay. All right. So that's kind of an all-natural foundation. There's a lot of
Yeah,
natural
everything
stuff
in
there.
this is renewable in this particular panel.
Well, Chris, we've been talking about the vacuum bagging technique, and that's really state-of-the-art these days. And we've got a little demo set up. Can you explain what we're going to do?
Yeah, this is a vacuum infusion process, and basically what we have is we could say this is a boat mold or something like that.
Yep.
And we put the fiberglass into the mold dry.
Okay.
So we stay clean, the whole 9 yards, and then
Yeah.
we put the vacuum bag on it, and we draw the air out of that vacuum bag. Mm-hmm. And then what we've done is we put some plumbing onto it. So
Yep.
we've got vacuum going to the part,
Yeah.
and then we have an input line, and this is where our resin is going to be put into that glass.
I see. So it comes in here,
Comes
and there's
in
a
here.
suction force
Yep.
over here.
So
Yes,
the
okay.
atmospheric pressure is going to push the resin out of the cup. It's going to force it through the glass, and then if we did all our math right, it will stop before it gets to the vacuum line.
Ooh, that sounds good. Let's try that.
You ready to go?
I'm ready to go. Let's go. All right. Yeah, I can see it starting to infuse the panel right now.
So here we go.
And this is a very uniform mixture,
Very
isn't it?
uniform, controlled consistency. So what we did was we weighed the glass and we figured out what kind of resin ratio we wanted for this.
Oh, yeah.
For this operation, and then we introduced how much resin we want in the glass.
Yeah.
And then
Gives it a
it'll
high degree of control.
High degree of control, and then there's no air. We're forcing all of it. We're replacing the air that's in there with the resin system.
Right.
So our void content has gone down, opposed to the cup and brush where we're making bubbles and forcing
Yeah, you
air
get
into
blisters
the
and all that 9
all that
yards,
stuff.
right,
So
yeah,
this
yeah.
helps a lot with that process.
Well, Chris, we just did a demonstration of this vacuum infusion or vacuum bagging process on a small scale part. And of course, doesn't matter the size of the part. We're in a full-size hull right now and use the vacuum bagging process on this as well, right?
Absolutely.
Yeah.
We set this so we put all the material in dry, went through that same process that you just saw, and this large 21-foot boat took about 48 minutes to get all the resin into the reinforcement in here.
Wow. So less than an hour.
Less than an
And
hour.
how long would that process typically take? How much are you shaving some time off a traditional approach?
Yeah, traditionally this would probably take a couple of days. You'd have to do wet on wet with the cup and brush and get people in here
Yeah.
and have to turn
Yeah.
molds and
Yeah.
just access issues. Yeah, this was a much simpler process.
So a lot simpler, and a lot faster, and you get better consistency, the resin to the dry material, right?
Absolutely.
Yeah.
We can dial in our resin to fiber ratios, and we can tell you what the part weighs before it's finished.
Yeah. Chris, we've been talking about different forms of creating fiberglass parts and through some of the more advanced processes that you're doing here. And this guy here, he's one of, a team of landing school students that's come in to put all the pieces that you create together, right?
Right. Yeah. We got groups of students in here, and we usually try and break them up into teams of 3 or 4, and then on larger parts like this, maybe as many as 6 students.
Okay.
To make all of the parts.
Yes.
So we'll make all the parts, all the small parts, hatches, and all that business, and then we'll bring those teams together, and we'll do that final assembly of the hull and the deck and all the parts, and do the final fit and finish
Okay.
of everything that we've been doing for the past 6 months that's taken us to get to this point.
About 6 months, yeah. So you bring all the fiberglass together, and then again, there's experts here that help counsel them on things like, railings, like stainless steel railings, the differences between different types of stainless steel and the different types of wiring, right? Because
Right.
you're teaching them ABYC standards, I would guess. So they go out in the industry, they know what wire to use, what connectors to use, all this stuff, right?
The students in any of the programs here, they get to see all of the instructors in the school. So
Yes.
the systems students might come over and see the composites instructor, me, and then the system instructors might come over here and advise the composite students on how to make this ABYC ready. And we also have a naval architect that we work with to make sure that we're up to those standards. And
Right.
we bring all those guys in here, we break steel and all kinds of fun stuff. Kind of get the whole full gamut of the whole thing.
So it's a team effort,
Team effort.
multidiscipline effort.
Absolutely.
Yeah. Well, Richard, you know it's hard to believe, but we've run out of time for the show today. So
How about that?
I know. And we've actually covered a lot of ground. So we started with the talking about the design and the build of the Arundel 19, and we've talked about composites, and we've talked about different types of green designs. And so we've really covered a lot, particularly some of the newer stuff you're involved here at the school. Before we wrap up, is there anything you'd like to add?
Yeah, I think it's been a productive day. You really saw the school stem to stern. We did spend quite a bit of time focusing on our new ventures,
Yes.
on this zero carbon boat building, on doing life cycle analyses on the materials that we use to build our boats. But despite that, the school's been around for almost 40 years now.
Right.
And our core mission is to prepare students for careers, rich careers in the marine industry, and to have them really respect the traditions of the past. So we're building upon that very strong foundation in these new ventures. But the school hasn't, in some ways, hasn't changed a lot since I was a student here back in 1986.
Yeah, so you got to blend in the old and new. Now, if someone around the country is watching this show and they have some questions on the school or maybe some of the advanced techniques you're using, is there a way they can reach out to the school?
Yeah, you bet. So I encourage all the folks to visit our website, and that's just www.landingschool.edu.
Okay.
So we've got a really great website. We also host what are called LibGuides, and so if you use your preferred search engine, so perhaps Google,
right.
That's not a product endorsement.
No,
But if you use Google and Google LibGuides, LIBGUIDES,
Okay.
Landing School. We have a lot of online literature available for folks out there, whether it's in yacht design, marine systems, composite boat building, or wooden boat building. Really answer a lot of the questions that people might have after watching this special.
That's very cool.
It is cool.
Well, thank you for joining me.
Paul, thanks so much for coming. It was really a lot of fun.
You're welcome. And thank you, Smart Boating viewers, for joining us. If you have any comments or questions, come to our website at www.smartboatingus.com. Thank you.